Welcome to College Algebra. In this lecture video, we're going to talk about our rational inequalities. Okay, the last objective for lecture video 4.5. So, in the last video, I showed you how to draw rational function by hand. So, hopefully, by doing that, it will help us here with the rational inequality. So, very similar to the polynomial inequalities that we done before. For the rational inequalities, find the vertical asymptotes first. Okay, that give us that kind of tell us, what we're going to see on the graphing calculator that is not really there. So we got to find a vertical asymptote, so we kind of have an idea what we are looking at after we graph it. Find the real zeros, or what they call the critical points. Here, these real zeros, I'm gonna actually basically talking about the x-intercepts. Okay, I might use that wording more now. Okay, but the real terminology is called the real zeros. The rational and the irrational zeros. That's what we're gonna find, and those are the one will cross or turn at the x-axis. All right, we're gonna graph the function. Okay, either in a graphing calculator or on the number line, and we will state our solution using the interval notation. So one of the most important thing to understand right away is make sure your rational function or your rational equation, all of them is on the same side of the equal sign. So here I got my function is greater than or equal to 0. So let's find the vertical asymptote. The numerator and denominator, if I factor them, there's nothing can be cancelled. So set my denominator equal to 0. And that will tell me my vertical asymptote is going to be x equal to -4. So my function, so my graph, okay, will actually split into two parts because I only got one vertical asymptote. Alright, find the real zeros or find the x-intercept. So that's when we're going to set our function equal to 0. Find x when y equal to 0. Okay. So same trick as I showed you in the previous video. Using cross product, x minus 4 times 1 still going to be x minus 4. Set it equal to 0 times these two terms down here will be 0. So if I move my -4 over, x is equal to 4. So I have a x-intercept, okay, all the real zeros at x equal to 4. Alright, let's graph it. And I'm gonna kind of point it out where are the things we just found here on the graphing calculator. Alright. So I got two terms on top, put them in the parentheses, divided by x plus 4. Let me go back to the standard window real quick. Alright, so just like what I expected, one vertical asymptote. Divide my function into two parts. So my vertical asymptote at x equal to -4. 1, 2, 3, 4. So I got a vertical asymptote right here. My function will never cross over there. Let me write it down too, okay? X equal to -4. Alright, I know my function will cross over the x-axis at x equal to 4. So let me make this into a blue point. Alright, 1, 2, 3, 4, right there. Okay. So now what I'm looking for is greater than or equal to 0. Greater than or equal to 0 means we're going to look on the x-axis and above. So where are the function that's above the x-axis? This part is above the x-axis. Okay. Will this function keep on going to the left, cross over the x-axis? The answer will be no, because when I find my x-intercept, my function only cross over the x-axis right here at this point. So this part will be from, so now writing the solution set, that will be from -infinity all the way to 4. Alright, I'm using a parenthesis for the 4 because the 4 is a vertical asymptote. Union, where else is above the x-axis. So if you look at this little piece after x equal to 4, that line is kind of darker up here above the x-axis. So that means from after 4, that part is above the x-axis right here. If you don't believe me, we can go to the table and check. Looking at to the right hand side of 4. So 5, 6, 7 for x. Look at the y value. The y value are positive. So that means to the right side of 4, the function is above. Alright, so, excuse me, this is -4, right? This is -4, sorry about that. From -infinity to -4. So now for my 4, I got to use brackets. Why? Because they're equal to. So it's going to be from 4, keep on going to the right. It's above the x-axis. Alright, that's how we write the answer in interval notation. Well, let's check out another example here. So this one right here, where I got one term on the other side, so I'm gonna bring this term to the left. I need to have everybody on the same side of the inequality. So this is gonna be 3 over x plus 4 minus 3 over x minus 2. Alright, less than 0. So I simplified this left side a little bit. I want this to be one term because what I really want to do is figure out what my denominator going to be so I can find my vertical asymptote. Okay. So right now I got subtracting of 2 rational expressions, so my LCD between the two got to be x plus 4 times x minus 2. Okay, so what does the first denominator has that that the LCD don't have? The LCD is missing, excuse me, what does the LCD has that the first denominator do not have? The first denominator is missing x minus 2, so we will take that times my numerator. So that will be 3 times x minus 2. Alright. What does the LCD has that the second denominator do not have? Second denominator is missing the x plus 4, so we will take the x plus 4 times my numerator, which is -3 times x plus 4. I want to write them as one term. So as you can recall in your previous algebra classes, you learn how to add and subtract rational expression. So we're doing the same thing here. Different way of saying the same thing. Okay, x plus 4 will go into x plus 4 will go into my new LCD how many times? My old denominator will go into the LCD how many times? X plus 2 times. Okay, because the x plus 4 cancels out. So the way I say it is just by looking at the old denominator compared to the new denominator and see what my old denominator is missing, because that will be going to it how many times. Alright, let's simplify the numerator real quick. Because I always have to watch out after I simplify numerator. Maybe my denominator something will cancel. Okay, maybe not. So this is gonna be 3 times. Let me do this on the side right here. Let me do it right here. So 3 times x is 3x. 3 times -2 is -6. 3 times x is -3x. -3 times +4, -12. Alright, 3x minus 3x cancels out. Negative 6 minus 12 is going to be negative 18. So my top will turn out to be a negative 18 over x plus 4. So for me to find the vertical asymptote as the first step, okay, after simplifying my numerator, there's nothing will be canceled with the denominator. So for my vertical asymptote, set my denominator equal to 0. Then my vertical asymptote is going to be at negative 4. The other vertical asymptote at x equal to 2. Okay. Alright. By simplifying ahead of time, it also kind of helps us to find the x-intercept or the real zeros, because now I'm going to solve for x when y is equal to 0. So all I'm going to do now is set this whole thing equal to 0. Use my little cross product. Negative 18 times 1 is negative 18. Set it equal to 0 times this thing down here will be 0. So that tells me negative 18 cannot equal to 0. So that means I don't have any x-intercept. Okay, this has got vertical asymptotes. Alright, so what do I graph? What do I put in my graphing calculator? This part right here. Originally, when I moved that term over, that's the one we want to graph. Because sometimes when we simplify, we lose certain characteristic out of the functions. Okay, something we mentioned when we were in chapter 3 lecture video series. Okay, always graph the original function. So I moved this over, so this is the one I'm going to graph. A little bit complicated though. I got two terms right here, so I'm going to say parenthesis for my first term. 3 divided by open parenthesis for my denominator, x plus 4, close parenthesis for denominator, close parenthesis for my first term, minus second term, 3 divided by open parenthesis for my x minus 2, close it, and close the whole second term. 2 vertical asymptote. Alright. So will I go over the x-axis? The answer is no, because I did not have any x-intercepts. Okay. So what are we looking at here? X equal to negative 4. 1, 2, 3, 4. So there's a vertical line. This is my vertical asymptote right here. And I have another one at x equal to 2. Sorry, I'm gonna move it over a little bit. There we go. You know what? I'm going to thin this out a little bit. There we go. Thin out my. There you go. Alright, so these two are my vertical asymptote. One of them is x equal to negative 4. The other one is x equal to 2. Alright, by looking at my inequality, I'm looking for from where to where my function, my y values are below the x-axis. There's no equal to, so everything will be using parentheses. So this part is below the x-axis. Okay. And this part is also below the x-axis. So that means from negative infinity, okay, coming from the left, approaching my vertical asymptote negative 4. Okay, union, the other part, starting on the right hand side of the other vertical asymptote, keep on going to the infinity. Okay, so the reason why I'm using parentheses, okay, for my negative 4 and 2, because those two numbers are what? Are my vertical asymptote. Okay, function can never touch the vertical asymptote. Alright. I'm gonna try, yeah. So there's some of these problems are similar. I'm gonna do this one right here with you. Tell you what, I'm gonna move my 9 over x plus 2 to the other side. So that'll give me 3x minus 9 over x plus 2. Now, I'm not quite sure if I ever talked to you about what I so-called the ancient Chinese secret. So basically, whenever I'm combining a whole number with the fraction, I can always use the little trick. What is x plus 2 times my whole number term, 3x? What's x plus 2 times 3x? Okay, I'm gonna write it out, okay? So that means that's 3x times x plus 2 minus my numerator, 9, over the denominator is still going to be what? X plus 2. Okay, a little ancient Chinese secret. And you can think about it just like if you have a mixed number, like 2 and 3 over 4, how do you convert mixed number into improper fraction? You say 4 times 2 is 8. And what does 8 do with the 3? 8 will plus the 3, which is 11 over 4. So why do we add the 3 on the top? The reason why we add, you can come think of it, is between the whole number and the fraction, there is actually a plus sign there. It's not a multiplication, it's a plus sign. So that tells us that whenever we combine a whole number with a fraction, I can say 4 times 2 is 8, 8 plus 3 is 11. So when I combine a whole number with a fraction, if I'm using a subtraction, I can still do the same thing. Okay, 4 times 2 is 8, 8 minus 3 is 5 over 4. If you don't believe me, you can put this in the calculator. It will tell you it's going to end up to be 5 over 4. So I'm using the same trick right here. Denominator times a whole number, then subtract my numerator. So I'm going to erase this. Okay, so I'm going to simplify my numerator a little bit and see if anything can be factored and reduced where you will cancel out with my denominator. 3x times x is 3x squared. 3x times positive 2 is positive 6x. And I still need to minus 9. Alrighty. Can I factor this thing? I can factor out a 3. Let me do it right here. 3x plus 6x. I can actually factor out a 3 right now. So that will give me x squared plus 2x minus 3. So if I continue to factor my trinomial, what times what is 3? 1 and 3. Since the last sign is a negative, the choice is 1 positive, 1 negative. So to end up with a positive 2 in the middle, I got to have a positive 3 and negative 1. So this is going to turn out to be my numerator after it combined, factored, and simplified. But I'm still going to be over x plus 2. So if I factor in my x plus 2, I will notice that there's nothing on the top and bottom can be canceled out. So as far as my vertical asymptote concerned, set my denominator equal to 0. I will only have one vertical asymptote at x equal to negative 2. Alright, let's find the x-intercept. To find the x-intercept, I'm going to find x when the y equal to 0. So my whole entire left side here, set it equal to 0 to solve for x. So if I use the same trick, 0 over 1, use my little cross product, what these things multiply 1 will be still the same thing. Set it equal to this times the 0 times diagonally here, that will still be 0. So now you can see why I went through all the trouble to simplify this, because I'm going to use it for finding the critical value or the x-intercept. So now divide both sides by 3. That will eliminate my factor 3. Set each factor equal to 0. I have x-intercept and 1 and negative 3. Okay. So vertical asymptote, 2 x-intercept. Alright, let me grab this function. What do I grab? Again, what do I grab? I grab what? This original part right here when I move that term over. Alright, 3x minus parenthesis 9 over x plus parenthesis x plus 2. And a lot of times students ask me, Mr. Chan, why can we just graph this from the very beginning and then look at this? Oh, this is a weird looking picture. Why is that? Because if you think about it from this perspective, x times x is x squared over x. The degree of a numerator is 1 greater than the degree of the denominator. That's why here I have a weird looking function using the slant asymptote here. Okay. Alright, yeah. Do we see like right here, these 2 points where it cross over the x-axis? Let's take a look. This is not the whole picture, I don't think. This is a little bit more into this particular graph. But what I want to find out is from where to where the function is less than 0. So my vertical asymptote is at x equals to negative 2. So there's a vertical line right here. That's x equals to negative 2. Alright, I have a x-intercept at 1. This is 1. And another one at x equal to negative 3. These are the only 2 x-intercept I have. Even though I might not see all the other pictures, I know that this thing going down somehow curve back up is not going to cross over the x-axis. Because if it does, I will have another what? I will actually have another x-intercept here or on this side. So looking for the part of the function that is the y value is below the x-axis. That's referring to here and here. Alright, so no equal to, okay? No equal to. So from negative infinity all the way to negative 2 is below the x-axis. Now, why do I use parenthesis for my negative 2? Because I don't have a, because I'm only have greater than. There's no equal to, so my x-intercept is using parenthesis. I also use parenthesis if it's a vertical asymptote. But so the other part that's below the x-axis is actually starting from my vertical asymptote all the way approaching 1. So that'll be from negative 2 to 1. So the negative 2 is a parenthesis because that's a vertical asymptote. Okay, the negative 2 and 1 is using parenthesis because they're greater than 0. There's no equal to. That's a little arrow. Okay, from here to here is the graph is below the x-axis. Okay, so that would be your interval notation for the solution. Alright, so now we have done vertical asymptote in this 4.5. We've done horizontal. In the slim asymptotes, I show you how to graph rational function by hand a little bit. Okay, so we can actually looking at each picture with a better understanding. And we also talk a little bit about your rational inequality and writing its answer as interval notation. Okay, so that will be all for your lecture video 4.5 series. Thank you for watching.